Hello, everyone. You are welcome to today's lesson, and today's lesson happens to be the last lesson on the topic binomial theorem. Okay, and in today's lesson, our main objective will be by the end of the lesson, you should be able to find the general term of any binomial expansion and use that to generate particular term or use that to find particular terms of what binomial expansions, okay, or of a binomial expansion. So basically our main objective would be finding the general term, because without, okay, the general term wouldn't be able to find particular or specific word terms. Okay, so without much ado, please stick and stay with me. Mr. Hackman, and I am going to walk you through, okay, today's word lesson. And as usual, I'm trusting you. I know that you make the class very interactive. Okay, so as you have on your screens, okay, we are looking at finding the general term and, okay, particular terms of a binomial expansion. So the general term of a binomial expansion of, okay, a plus b to the power n is given by, so this is the formula. Okay, so this is all that you need to know in terms of the formula. And this formula is for a general expansion of a plus b to the power n. Okay, just as you know, in our binomial expansion, if you know the general expansion of a plus b to the power n, you can use that to generate some particular expansions. Okay, because it's the theorem out of what the general that we use to do that of what the particular. Okay, so quickly, under normal circumstance, okay, my duty is to give the formula to you and help you to use the formula. However, with this one, okay, we are going to indirectly, okay, prove the formula together so that in case maybe you forget, I'm not saying that you should forget anyway, but in case you forget, you have your way around as to how to generate the formula, okay, irrespective of the time that it will take, because you know that if you are not able to quote the formula, you wouldn't be able to solve the question. So if you spend a little time to indirectly prove the formula or generate the formula yourself and use it, it will be better than you have forgotten the formula totally, and therefore you are not able to salvage any of what of your marks. Okay, so this is it. Let's go. So the proof, as you can see in the formula, you can see that we have, okay, this formula deals with word combination. So it means if you are going to prove, we are going to rely on the binomial theorem that involves word combination. So in this case, we know if you have a, okay, oops, if you have a plus b all to the power n, and you know that your n belongs to a positive integer, okay, we said, okay, the expansion will give us n combination 0. Help me, we are revising indirectly. N combination 0 here, help me with the theorem. My professor, the whole class, let's go. N combination 0, a to what power?
A to the power n minus 1.
N minus 1, then b to what power?
1.
Oh, if you add, you should, are you sure to be 1? Hey, you people, you've forgotten the formula like that. If you can't quote the theorem, then it means you can't continue. Remember, your first term will not be this. It will be n minus 0, so it will be n. Your its power will start from n. Remember, it will not start from a minus 1. So at this point, you are doomed. You get the point? Okay, so please, okay, let's learn to quote. At least we've been working with the formula, so by now it should have, okay, yeah, consciously or unconsciously, it should have been, okay, at our fingertips. Okay, so let's go. A to the power n, b to the power 0. Do you agree?
Yes, please.
Okay, so let's go now. So plus what? N combination what?
1
1. Then your a,
to the power n minus 1.
n minus 1. I can hear only one person talking. I said the whole class. Let's go. So you should all unmute. A to the power n minus 1. B to what power?
1.
1. I can still hear only one hand.
One.
Okay, so plus
N combination 2.
N combination 2, very good.
A to the power n minus 2.
N minus 2.
B raised to the power 2.
Okay, so B squared then plus.
Ellipsis.
Okay, you want to bring your ellipsis now. Okay, let's generate one more term. Okay, so
N combination 3.
combination 3. A to what
A
power?
raised to the power n minus 3.
Then B.
B raised to the power 1.
Okay, then plus
3.
our ellipsis, then plus the last
Yes.
one, which will be N combination. What have you? Is that not it?
Yes.
Okay, so for the purposes of what I'm going to do, okay, I am going to end here. But you should obviously know that, okay, this will not cater for all the terms. We've written only the first, the second, the third, and the fourth term. So the first 4 terms. Okay, now, okay, you have not done series and sequence, but no issues. Okay, we will do it anyway. Okay, that's why remember I told you that the way the new syllabus is structured, okay, it leaves a lot to be desired. It doesn't put students, okay, at the center in the sense of how, okay, the topics are structured, because you will need series and sequence, and I am of the opinion that we should have done that before binomial theorem. You will also need combination, because binomial theorem has combination involved, so you should have done combination before binomial theorem. But nonetheless, okay, this is what we have before us. So we should be able to find our way around rather than complaining. Okay, because the world has no room for those who complain. So let's look at how to find our way around. So in terms of series and sequence, when we are talking of terms, terms are denoted by U subs. So here my first term will be represented by U sub 1. Okay, so my U sub 1 here will be the first term of the expansion, and that is n combination 0. Okay, a to the power n, b to the power 0. Do you agree? Okay, U sub 1, basically, the sub will
Yes,
tell
sir.
you the term. So that's the first term. So the second term will be U sub 2, likewise. Okay, so what do we have? That will be the second term of our expansion is what? N combination 1. Help me. A to what power? N minus 1, then was then b to the power 1. Okay, so on the same vein, your third term, which will be represented by U sub 3, will be equal to n combination 2, a to the power
The
n
power
minus
n
2,
minus
then b
2.
was squared. Okay, so let's move on to maybe U sub 4. And U sub 4 is representing which term? The fourth term. Okay, so now you get the drift. So that will be equal to, okay, so that will give us n combination what? Combination 3, is that not it? Then a to the power n minus what? 3, then b what? Q. Now, at this point, we are going to stop and do a little bit of observation and analysis. Okay. Now, if you look at what we have before us, okay, I want your full attention here. Okay, if you look at what we have before us, in terms of combination, anytime you are dealing with combination, you should always have, okay, n combination R. I think I introduced, okay, this to you at a point. Okay, so you should know this. So it means, okay, that if I have this, please take note. If you observe critically, okay, I think I can move on to the next page, or let me rule a line here and continue so that I don't have to be moving, okay, backwards. Okay, so now, okay, n combination R. This is, let me clear this, okay, quickly. All right, so forgive me. So quickly, let me clear that. Okay, n combination R. So this is what we are going to do. Okay, observe. Okay, so here you can see that I said you have n combination what? R. Okay, all right. Now, if you look at what we have critically, okay, the combination that you have here, you can see that you have n combination 0, n combination 1, n combination 2, n combination 3. Is that not it? The combination in each of the terms. So it means your R is starting from 0, okay, and from where we've gotten to, your R is ending at 3. Is that clear? Are you with me, my professors?
Yes, sir.
Okay, so assuming I
Yes,
have
sir.
a particular U, okay, I don't know the sub. Okay, so we'll come to the sub, okay, very soon. And I'm dealing with N combination R, a general one. Okay, so let's observe critically. You can see that if your R is 0, what is the sub for the U?
1.
1. If your R is 1, what is the sub for the U?
2.
Let me take the points out. Okay, so if it is 2, what is the sub?
3.
Okay, if it is 3,
3.
what is the sub?
4.
Okay, so do you
4.
agree with me that the sub is always 1? I mean, I'm talking about the sub for the U's. Is always 1 more than your R. Do you agree?
Yes, please.
You agree. Can you see that?
Yes,
Can you make
please.
that observation? Okay, fine. So
Yes,
if that's the
please.
case, then it means I'm going to write this. Okay, we thank God you are smart and you are following. So can I say that if this is R, this will be R plus 1? Is that clear?
Yes, please. Yes, please.
Okay, very good. Then we are going to get A to the
Yes, please.
power. Okay, now let's see what we are going to do. Okay, we are going to have here. Okay, when this is 0, you can see that what you have here, the n that you have here, can you see that it's the same as n minus 0? That's the power of the
Yeah.
A. Can you see that?
Yes, please.
Okay, when your R here is 1, you can see that you get n minus 1. Is that not it?
Yes, please.
Okay, when it is 2, it is n minus 2. So it means you always subtract your R from the n, okay, in terms of the powers of the A. Do you agree?
Yes.
My professors, who want me to come again? We are trying to more or less prove the formula that we have before us. I should come again, and from where, my professors?
Please, me, Marilyn.
Okay, from where? From Maryland, long time. All right, from where? From Maryland, from where? Where do I start? At least how to connect the sub here and the I mean the sub for the U and the R. Okay, I think we should all be fine. Prof. Marilyn, are you fine?
Sir, this one was quite blessed. I couldn't see what you were writing.
Oh, then it means please. Okay, was my screen blur at everybody's end?
No, sir.
No,
Okay,
please.
then it
Not
means
at
it's
all.
your network issue. If it's network issue, then I'll plead with you. Other than that, we are not going to move forward. Okay, so
Okay.
I will plead with you. Okay, try and relate. If you are not able to relate, when you get the video, then you take your own time, listen, and what you fill in the gaps. Is that clear?
Yes, sir.
Okay, but I'm going to, I guess, okay, there was a resounding yes when I asked whether you understood how we got the sound for the R. Okay, so now let's go to the A. So it means if there will be any problem, it will come from what the A. So let me quickly go and do this just to buttress, okay, or drum home a particular point. So I'm going to write this just for convenience sake. Okay, so I'm going to write this as n minus 0, which will give us n, but usually we don't write it. So you can see that if your R is 0, it is n minus 0. Okay, if your R here, which is now 1, it will be n minus 1. So if this is 2, okay, it is n minus 2. So it means if this is R, it will be n minus what? When it is 0, we write 0 here. When it is 1, we write 1 here. It will be minus 1. When it is 2, it will be minus 2. When it is 3, it will be minus what? 3. So when it is R, it will be minus what? Minus R. I hope you get the point. My professors, I hope you are following.
Yes, sir.
Yes,
please.
Okay, we
please.
are just doing a bit of analysis, okay, from what, okay, we have before us, okay, especially in terms of the terms. So let me go and clear what we have here too, because I will need room. Okay. Okay, so now let's come to the B. Oops. Okay, let's come to the B and its power. Okay, so the B, if you look at when you have what this to be 0, okay, the B, the power is what? 0. When this is 1, okay, the power is 1. When this is 2, I hope you can see the cursor. Or let me point. Okay, when this is 0, 0. When it is 1, 1. When it is 2, 2. When it is 3, 3. So it means when it is R, it will be what?
R.
It will be R. I hope you are all with me.
Yes, please.
And is this not the same as the formula that we have here?
Yes.
Yes.
Okay, it's the same. Okay. Actually, I created another space, okay, another slide, okay, to continue. Okay, but I squeezed it here because I wanted you to see exactly where we can make that observation. So this is where the formula is coming from. So it means if I know this formula, okay, that's the general term formula, okay, I should be able to find some particular terms because sometimes, okay, you can see that so far what we've been doing, okay, Prof. Caroline, please allow me
Mr.
to land. I
Hartman.
will give you the opportunity to
Okay,
ask
sir.
questions. Okay, thanks for your understanding. Okay, so I was saying that so far you realize that anytime you are asked to expand, given a binomial, okay, to a certain power and we are asked to expand, it's either we expand and get all the terms or we expand up to or a particular term. But so far, we've not been able to, or we've not solved a question which involves us picking one particular term. Let's say expand and give us just the third term, the fourth term, okay, the fifth term. We are only interested in a particular term. So if you are interested in a particular term, okay, you don't have to expand and go and pick only that term. If you do that, then it means you are not privy to this information. You don't know how to find the general, okay, term formula of that binomial expansion, and therefore you can't use it to what? Find what? The particular what term. So if you know this, if you're able to get the general term of what? What do you call it? A binomial expansion. If you are asked to find any particular term or any specific term, you should be able to what, do that by using the general term, okay, formula. So that's all that we are going to do. We are going to generate the general term formulas for any binomial expansion that will be given. Okay, then use it to find particular term. Particular terms will be maybe the third term, the fourth term, the term in s okay, to the power 4, the term in s to the power 7, or maybe the coefficient of a particular term. Okay, so that's all that we are going to do, okay, today. So Prof. Caroline, you may now, okay, ask your question before Prof.
Mr.
Frank
Hartman.
comes in. Yes.
Okay. So, in the formula, the formula you wrote at the top, the one in green. Sir, please, the letter after the N. So is it C or is bracket? Because when you
Which one?
rewrote it, it's like
This one?
bracket. Yes.
Oh,
You
it's
wrote it as C.
combination. If you are familiar with this, N combination R. I even said
Yeah.
that before, okay, we started generating. We said that in the formula you can see combination there. It's not bracket.
Okay.
You know, how do we write bracket this way? In any case, if there is bracket, then you cannot have only open bracket. There should be a closed bracket. Bracket should be
Okay,
there.
sir.
You get it? So it's not bracket.
Okay.
Okay, Prof. Frank.
Please, is it always written as UR plus 1, or it can sometimes change?
Are you talking about this?
Yes, sir.
Okay, so as for the sum, it will be the same. R plus 1 is the U that in series and sequence. Sometimes we can use A, we can use T. Okay, but in our jurisdiction, we most often do not use U to represent what? Terms of what series and sequence. So in some books, you will see, okay, A sub R plus 1 is equal to what you have there. But you can see that if I use A, there will be a conflict. So usually when A is used, then they will rather use X and Y, okay, to represent your terms, okay, in the binomial, because there will be conflicts. You get my point?
Yes, sir.
Okay, and we can also use capital T sub R plus 1, T for terms, okay, and that will be equal to, if you use T, you can go by this, because there wouldn't be any conflicts. You get my point?
Yes, sir.
Okay, so that's it. But usually, like I stated, okay, we use what U to represent what terms in terms of series and sequence. So if you see A, if you see T, okay, it's still representing terms. Is that clear? Okay, so now if you are fine, let's see how best we can make use of this information before us to solve the following worked examples. Okay, so quickly, let's look at, okay, this question, the first worked example. Okay, please, are you sure you are fine? Can I move on to our worked examples?
Yes, sir.
Yes,
Okay,
please.
all right. I've told you that this is the most technical aspect of, so if you get it, okay, you should be able to flex your muscles. All right, so worked example 1. In the expansion of 2 plus s to the power 8, find the A, general term, then B, the term in s squared, C, term in s to the power 5, B, third term, C, sixth term. Okay, so you can see that you will find the general term and the B, C, D, A, this should be E. So let me quickly do the change, okay, quickly. It's supposed to be E, not what, and this is supposed to be, okay, I think this is supposed to be D, then E. Okay, I did copy and paste and I didn't do the editing well. Okay, so I guess, yeah, now it's fine. So we can move on. Okay, so let me see. All right. I'm coming. All right, so give me. Okay, so I think we are good to go now. All right, so like I was saying, this will be the general term, and the B up to what? Up to E. We'll be looking at particular term because the term in S cube is a particular term. S to the power 5 is a particular term. The third term is a particular term. And what the system equally a particular term. So let's see how, okay, now that we've understood the question, okay, we know the demand of the question, there is nothing salient for us to underline. So what do? We write solution, then we come and write the major question number. Is that clear, my professors?
Yes, please.
Okay, then after that, okay, when we have the major question number, we can extract what? So you write given, and what are we giving? We are giving 2 plus x, okay, all to the power 8. I will need your maximum attention here. That's the first example. So make sure nothing escapes your ear and even your eyes. Okay, so this is what we have. Now, A, we need to find a general term. And take note, without a general term formula, you wouldn't be able to find the particular terms. So even if the question specifically straight away asks you to find a particular term, you have to first of all generate the general term before you can find a particular term. Take note. So in this case, I come to A. A, I need to find a general term. Is that not it?
Yes, sir.
Okay, however, you know the general term of what? A plus B to the power n. So I'm going to write it later. I'll refine my presentation. But, okay, so here I'm going to quote a formula. Okay, the general term of A plus B to the power n. Okay, is equal to here. Let's go. N combination R, A to the power n minus R, then B to the power R. You know,
Yes.
right?
Yes,
Yes,
please.
sir.
Are you sure?
Yes, sir.
Hey, was that the formula I gave you?
No, sir.
Sir, please.
No, please remember, if you write this, okay, yes, we could be, but remember the general term formula is a relation, it's a formula. A formula is supposed to have left-hand side and right-hand side. Is that not it? Okay, so
Yeah.
if you write it this way, you are not wrong. This is the formula anyway. Okay, I mean what we have here, but I prefer and we prefer you write it, okay, this way going forward. So let me clear this. Remember, there will be USAP. I hope you are with me.
Yes, please.
Okay, which we ignored. So take note. Okay, so it's given by the general term of what this is given by. Okay, so it's U sub R plus 1 is equal to, so now let's go. N
N
combination
combination
R,
R.
A to the power
A
N minus
N
R, then
minus
B to
R
the
B
power
R.
R. Okay, B to the power R, not BR. Okay, so the meaning changes. You
B
agree
to the
with me,
power
right?
R.
Yes, very good. Okay, so that's it. So can I say that, okay, so I'm going to be smart. So I will write, okay, therefore 2 plus x to the power 8. 2 plus x to the power 8 will be equal to, okay, in terms of, okay, let me, I didn't proceed. Okay, well, I got distracted at the point, so forgive me. Okay, all right. So what are we asked to find? Therefore, the general term of, because we are asked to, so therefore, general term, oops, okay, general term, general, okay, term of, what's the expansion? 2 plus x all to the power 8, okay, will be equal to or will be given by is, so let's go. It will be u sub r plus 1. If you compare, what is our a? If you compare this one with this, our a is what?
2.
2. So it will be n combination r and your a, which is 2. But you know, I've told you, you always put it in brackets. 2 to what power?
N minus R.
N minus r. And what is your n? So you know the parameters in the formula. So I told you, maybe I was thinking that, okay, so you know the parameters in the formula will be A, okay, B, and what, and N. Is that clear? As for R, we know. So A, we know is equal to 2. Okay, B, we know is equal to what, X. Okay, and N, we know is equal to 8. Do you agree?
Yes, please.
Okay, so let's go and do the needful. Let me, somebody, okay, I think, okay, so let me clear this. All right. So we are on the right foot. Okay, so let me go and clear. Oops. Okay, so please, we are going to clear the. So it will be 8 minus r. Do you agree?
Yes, please.
Okay, so you know your n to be 8. So 8 minus r. Then b, what is b?
X
X
raised
to
to
the
the
power
power R.
to the power
R.
r. Is that clear?
Yes, please.
Okay, so this is how I want you to write it. Someone can choose to ignore the brackets and therefore write it this way. Okay, so that will be equal to, okay, n combination r. And I was expecting you to tell me something which is late in coming. It's giving me the indication that you are not fully following. You can see, don't you know your n?
8.
It will be
Sir, please, the N in front of the combination is supposed to be 8.
very good. It's supposed to be 8. You know your n. Okay, so now let's go and do the needful. So it's supposed to be, okay, 8. So I'm fully convinced that now you are following. So in this case, I'll write 8 combination. If you write it this way, combination R, then dot, you know dot is the same as what? A dot here is the multiplication of the product dot. Then I'll have 2 to the power 8 minus R, then dot what? X to the power what? R. Is that clear? Okay, so
Yes, please.
now we've been able to deal with what? The question A. Let's go and look at that of what question B. Okay, any questions before I move on to question B? Prof. Marilyn, are you able to follow now? Okay, Prof. Frank,
Please, I'm a bit confused at the last part.
the last part, which one? This one.
Yes, sir.
Okay, remember in your, okay, this particular expansion, this is the general, okay, expansion. The particular expansion, you know the values, okay, for A, B, and what, and N. So in the formula that you've quoted here for your general term, okay, what do? Substitute these parameters. So wherever you see A, it is 2, wherever you see B, it is X, wherever you see N, it is 8. So that gave us this. And I said this will be, okay, you can see that the bracket here indirectly is representing product, sort of. You get it? Okay,
Yes,
but
sir.
I said if your substitution, whatever that you are substituting, the first one, always put it in bracket per the advice that you've been given from the beginning. Okay, so you could have ended here. There is nothing wrong with that if you end here. Only that I said that the matured way will be you, because I can remove the brackets, especially when I realize that the quantities that I'm substituting, okay, is not what's negative or are not negative. None of them is negative. In that case, I can ignore the bracket. But if you ignore the bracket and you write it this way, okay, 8 r, 2 to the power 8 minus r, then s to the power r. Without the dot, it will still carry the same. You got a point?
Yes, sir.
Okay, you should know that I introduced the dots, okay, for you to know that it is multiplying. So it's just throwing more light on the fact that it is multiplying. These are factors. The first factor, the second factor, the third factor. All correct now for Frank.
Yes, sir.
Okay, so now that your general term, okay, you know your general term for the expansion of 2 plus x to the power 8, you are in the pole position to find any particular what term. So let's go and look at what B, okay, which deals with a particular term. So as I move from the sub question A to the sub question B, I leave a line. So B. Professors, are you there?
Yes,
Yes,
please.
sir.
All right, Prof. Abubakar, it seems your environment is a little noisy. So if you could mute, unless maybe you want to ask a question or answer a question. All right, so now we are looking for the term in what? In s squared, is that not it? Okay, so let's see. For s squared term, or term in s squared, I hope it's the same thing, is that not it?
Yeah.
Okay, it's the same. All right. So for s squared term, this is all that you need to do. You can see that your term formula now depends on r. So if you know the value for r, okay, you know any particular term. But here, because you are looking for s squared, it means the power of your x should be 2. So for your power of the s to be 2, what will be the power of the r? I mean, what will be the value of the r? Do you agree that it should be 2?
Yes, sir.
Okay, so for s squared term, r should be equal to what? 2. Okay, so in this case, what are we going to write? Okay, so I'll write therefore, okay, I was asked to find a term in s squared. So I'll write term in s squared, okay, will be given by u sub, you said your r is 2, so that will give you 2 plus 1, am I
2
right?
plus 1.
Okay,
Yes, please.
as you mature, you write this, you do the 2 plus 1 mentally and write the 3 there. You get it? This is the first one, so obviously I won't present it the matured way. So that would be equal to, now you get 8 combination 2, then what? Okay, 2 to the power 8, man, okay, we are using this. So, or even if you want to use this, okay, assuming you use this. So it will be 8 minus what? 2, then,
2.
okay, x, which is what? Still x, okay, squared. Is that okay?
Yeah.
Professors, are you with
Yes.
me? Okay.
Yes, sir.
Yes, please.
This is the final one. Usually we use the final one. So for consistency's sake, let me equally teach you to do the right thing. So we are going to use the final one. So I will use the dot product instead. So the 2, this will be here, dots, then the dots will be here. Is that clear now? So 2 to the power 8. Let me write the 2 maybe big for you to see that. So you are not done, because this can be further simplified. So that will be equal to. So let's go and simplify this. 8 combination 2. I'm waiting. The calculators.
28.
Okay, so that will give you 28. Then times, okay, 2 to the power 8 minus. So as you mature, you do this one mentally. So like I said, so this will be u sub 3. Is that not it? So I should have written u sub 3 instead. Will be equal to here. Let's go. Then you get 2 to what power? 8 minus 2, which is 6. Is that not it? Then times x what? Squared. So let me move on to the next, okay, page. Or let me even squeeze. Let me see whether the next page. Okay. So we are going to get equal to here. Let's go. 28. Am I right? So you get 28, then 2 to the power 6 times 2 to the power 6 is what? Oh, you should
64.
you should know this offhand. 64. Then times what? X what squared. So let's multiply this and see the numerical coefficient. So 28 times 64.
1,792.
792. Okay, then you attach your S squared. Okay, so the term in S squared will be 17, or that is 1,792 S squared. So that will be the term in S squared. You get it?
Yes, sir.
Okay, so it means, okay, here you can see that we didn't do the full expansion before we went to extract what? That term that will be in S squared. We've been able to extract that term without giving what? The full expansion. So that's the usefulness of the concept that we are, doing now. Is that clear? Okay, so let's go to the C. Maybe your understanding will be better. As we move from B to C, you leave a line. C, what are we looking for? So for which term? For the term in x to the power 5, is that not it? So for x to the power 5, okay, term. What will be, let's go to the general formula. There's a general formula that will tell you the value of the R. So what will be the value of the R? If you want the exponent to be 5, what should be the value of the R?
6.
Hey, welcome.
5. 5.
If the value of the R, is 6, then you get s to the power 6. But we are looking for s to the power 5. You get it now?
Yes, please.
Okay, so be careful. All right, so that will give us R must be equal to what? 5. So on that note, I can say that therefore, term in s to the power 5. Okay, if I like, I can choose not to. So this time round, I am going to write is equal to. I won't write the u sub whatever. Okay, so now let's go. That will give us 8 combination
8
5.
combination 5.
Then 2 to what power? 8 minus
2
5.
to the
8 minus 5, which is 3. So you can do that. Is that clear? You can do it mentally. Is that clear?
Yes, sir.
Okay, then times s to what power? 5. My professors, I hope you are following.
Yes, please.
Okay, which will give us, so this can be further simplified so you don't end here. Because there's a value, there's also a value. So give me 8 combination 5.
56.
Okay, so 56, then times what? 2, cube. 8, then times what? X to the power 5. My professors, are you there?
Yes, sir.
Okay, so the last statement, will be 56 times 8.
448. 448.
Okay, so 4, 4, 8, then x to the power 5. So this will be the term, in x to the power 5 without necessarily expanding. You get it?
Yes, sir.
Okay, very good. All right, so 2 more to go. All right, we'll do more. Basically, that's what we are going to do today. So don't worry, we'll do more. Okay, so then D. If you are moving from C to D, that's where you leave a line. So you leave a line, then you come to D because you are moving from a sub question to another sub question. Otherwise, you don't leave any line. So D, what are we looking for? Okay, so for the third term. Okay, and here, how do we know? I've told you that after generating the general term formula, what you need to find particular terms will be the value or values for R, and it will always be just one value for a particular term. So let's see. For the third term, let's go back to what we have there, the formula. For the third term, what do you think will be the value of what R?
3.
3. Okay, 3. That's what you said. Is that what you do? You all agree that for the third term, R must be 3?
Yes.
Yes, sir.
No,
You agree?
please.
You agree?
No.
You don't agree? Okay, so those of you saying no, what will be the value of your R? It will be
2.
it will be 2. Please take note. Okay, those of you who said 3, let's come and substitute the 3 into the general term formula. If R is equal to 3, you get 3 plus 1, and that is what? U sub 4. U sub 4, is it representing the third term or the fourth term? The fourth term, right? Because we said the first term is U sub 1, the second term is U sub 2, the third term is represented by U sub 3, the fourth term U sub 4, and what have you. So please take notes. This is the advice. If in the question, take notes. If in the question, the particular term that you are finding, you see x and its power, that's where you use the power of what? Of the x here in the general term expansion to derive that R that you are looking for. However, if you are asked to find a particular position in terms of, you can see that here is third term, a term in terms of whose position is given, third, okay, sixth. So you can see that these are positional what terms. So in this case, if you have the third term, you have to rely on the sum for the U to generate that particular term. So for the third term, you know that R plus 1 should be equal to 3. So that means R should be equal to what? 2. Is that clear? Okay, Prof. Marilyn, are you following? Prof. Frank? Prof. Daisy, are you there? Are you equally following? Prof. Marilyn, are you here? Prof. Frank, can I hear from you, please? Are you following?
Yes, sir.
Okay. Prof. Daisy, are you here? Okay, all right. Okay, all right. So now let's go back to what we were doing. Okay, Prof. Yeah, Pokua.
So please, I wanted to ask you that with the terms in with the terms in x squared, I found out that the u was equal to u plus 1, which was 3, and the terms in
You
x
said
raised to the power
you
of
mean what?
x squared,
Mm-hmm.
and the u was u 3, u sub 3, and the
Which is
terms
the
in
third term.
yes, and
Mhm.
the terms in x raised to the power 5 too, it was u sub 6. So I started to think that maybe it has to be 3 so that it will be also u sub 4.
Okay, that's why you said that the R must be 3. Is that not it?
Yes, sir.
Okay, so this is the point. Okay, it's good at least you've let me into your head why you came out with that answer or came up with that answer. But this is it. You can see that you said if your R is 3, let's substitute. If R is 3, I said you are going to get U 3 plus 1, which will give us 4. So it means whatever that you are going to find here will represent the fourth term because U sub 4 is for the fourth term. Meanwhile, the question is asking you to find which term. Prof, yeah, do you get it? The third term. Okay,
Yes,
so in
sir.
this case, you can see that, okay, the third term, per what we are doing and we are, yet to do. Let's look at this. So the third term, we said R must be equal to 2. So if you are looking for a third term, what have you, when you go on, you see that always your R will be, okay, 1 less than the term that you are looking for. Okay, and I said if you are looking for maybe third term, fourth term, positional terms, use the sum of the U, okay, to determine your R. So that's exactly what I was trying to, the point that I was trying to make here. Okay, so if you are looking for the third term, then it means you want the sum of the U to be what? To be 3 before you can get the third term, is that not it? Because U sub 3 is what is representing the third term. So you are looking for U sub 3. Okay, which indirectly we know is like U R plus 1. So it means your R plus 1 should be equal to 3, so that your R will be equal to 2. Is that clear? Are you getting my drift?
Yes, sir.
Okay, so you see why, okay, it was good for me not to have recorded the lesson and send the lesson to you. So now you are asking all the necessary questions and keep it up. Okay, so once you agree, assuming, let me go and clear that. Okay, so okay, if it happens to be a rough work, you will cancel it. But if it's a rough work, you do it at the extreme end, like what you have here. Don't let it interfere with your main work as an advice area. Okay, so quickly, let's go and continue with our solution, our presentation. So now let's see what we have there. So we are going to get, in this case, R must be equal to 2. Okay, so we are going to get, okay, so therefore, which term? Okay, so the third term. Okay, we know will be u sub 3, and that must be equal to. Let's go and carry out our substitution. To be 8, we know our r. So combination 2. Are you with me? Then 2 to the power 8 minus 2, which is 6. Okay, times x to what power? To the x squared. I hope you are with me.
Also,
Okay, so fortunately for us, we've done this. That's what we did in 1. So don't go and do everything all over again, because it's from the same question we can infer. So we know that we end up getting 1, 7, okay, 9 to x squared. So it means the term in x squared, okay, is the same as the third term. You get it?
yes.
Okay, so another term. So if I want you to find the term in s squared, I can directly tell you that find the term in s squared. Or I can indirectly tell you that find the third term. But you should know from what we've done that the third term is the same as the term in s cubed. Sorry, s squared, forgive me. Is my point well made? I saw a hand up.
Sir, please, yes. So it's me, Prof. Caroline.
Have I addressed? Because it went down
Sir,
very.
please, no.
Okay,
Yeah,
so
I wanted you to land.
okay, all right.
Okay, so,
Okay, so I've landed.
sir, please, since you said, sir, please, when you were solving for the B, like the third time, you got the same answer when you solve for the, yeah, for
The,
the term in
the
X,
B and the D.
X and 2. So, like, yeah, when you're solving the D, like, you got the same answer as the D. So, like, I've noticed something because I solved the last one, which is the E. And I got the same answer that I got in the C, which is the term
So
in X,
I
X and 5.
intentionally said the question this way. Okay, just for you to know that, okay, if you are looking for the third term, okay, it is the same as the term in S squared in this your expansion. Okay, if you are, so that we don't have to do more work there. If you are looking for the system, it will be the same as the term in s to the power 5. And you agree with me that if you expand this without even you knowing the formula, the first term will be a constant term. The second term will be a term in x. The third term will be a square term. You get it?
Yes,
Just by
sir.
looking at it. Okay, if you
Yes.
expand this, because the first term is a constant, if you expand, in the expansion, the first term will be a constant, the second term will be the term with x to the power 1, and the next term, which is the third term, will be the s squared term. So the s squared term is the same as the third term in this expansion. And if you expand to, you realize that the term s to the power 5 is the same as the sixth term. Okay, Prof. Frank.
So please, the question C, when you were solving it, you didn't use the UR plus 1. You just did it
Yes,
like
remember
U
I
added.
said, listen, Prof. Frank, I won't even allow you to land. Remember I said, if you are looking for positional terms, that's where you use the sub for the U. But if you are looking for x to a certain power, use the general formula. The general formula, use the power of what? The R. Equate the power of your R to, okay, the power of the S that you are looking for, and solve for R. And the other one, when you are looking for positional, okay, equate the sub of your U to the positional, the position. So if you are looking for S to the power, let's say 4, a term in S to the power 4, come to your S power in your general term formula. Okay, the power, equate it to the power that you want. So in this case, if I want S to the power 4, okay, I come to the general term the power of what? The x, and I equate it to the power of what I'm looking for. So it will be r is equal to 4. You get it?
So does that mean you should have removed the +1 over here
Which plus 1?
in the B?
In the b. Which, this one?
Yes. Yes.
No. Once you know your r, you just come and substitute. Okay, because with this one, you use the power of the x to determine your r. So once you determine your r, just come and substitute. So it means if you substitute, you will be what? R plus 1, which will be 2 plus 1, which will be 3. So it means the third term, that will give you the term in s squared. Prof. Frank, I don't know if you get my point. We've not removed anything. Even with this one, the last one that we're looking for, with this one, okay, we didn't remove anything. We use r is equal to what? 2, because we said r plus 1 should be equal to 3. Therefore, r will be equal to 2. So once you know your r, just go and substitute that into your general term formula. Wherever you see r in the general term formula, as simple as that. But we are saying, okay, that for your work to be easy, this is just the extra information, the smart information. Okay, basically, if the term that you are looking for, okay, you are told the variable and its exponent, okay, go to your formula and check the variable, the exponent in the general formula and equate. You want s okay squared, but this is s to the power r. So under what circumstance will the power here be 2? It's only when r is equal to 2. Do you agree?
Yes, sir.
So that informed us, okay, yes, for the decision for r is equal to 2 for the s squared. And if r is equal, you can see that when you substituted r is equal to 2, we ended up getting a term that involved s squared, which is the term that we are looking for. So if you had gone for r is equal to 3 here, you realize that you end up getting s cubed, which is not the term that you were asked to find. You get the point? And with this one to x to the power 5. Okay, so I come to my formula because the question is specifically giving me, I know the power of the power that the x must take. Okay, so here I don't know the power, but the power depends on r. Okay, so under what circumstance would this r here, okay, be equal to what? 5. It is only when, will give me the power of 5. So it will be what? When what r is equal to what? 5. So just equate the exponent when the variable is given in the question. Okay, and its exponent, just equate the exponent in the variable in the question, of the variable in the question, and the exponent of the variable in your general term expansion or formula. However, if you are looking for positional terms, okay, particular term, here you know the exact term, you know the third term. Here, do you know the exact term? You don't know whether it is exact term in terms of position. The s cube, when you are given s squared, you don't know the exact term in terms of position. But if you are given the exact term in terms of position, that's where I said you use the sub, okay, to find your r. Because if I want the third term, it means my sub here should give me what? 3. Because the third term is represented by u sub 3. And under what situation will my sub here be 3? It's only when r is equal to 2. And I said you can equally get that by writing r plus 1 is equal to 3 and solve for r, which will give you r is equal to 2. Is my point well made, Prof. Frank? Prof. Frank, is my point well made?
Yes, sir.
Okay, all right. So now we are going to do more. We are left with the last one, the system. Okay, I think indirectly some of you have done that. So let me clear this and come and continue here. I'll rule a line. So assuming I've exhausted my page and I'm going to move on, I'm going to write, okay, I'll rule a line here. Okay, then come and continue. Hey, Prof. Frank,
So does that mean the question C was U sub 6?
question C.
Yes.
Yeah, it is u sub 6 that will give us the s to the power 5. Because if you go and substitute, you get u sub 6. Okay, because remember I said we can ignore the sub, so it will be u, r is 5, so it will be 5 plus 1, which is 6. So it's u sub the system that will give us this. And
Okay, sir.
I didn't want her, so you can see that it's coming out. And when we do the, I didn't change. Okay, I did copy and paste. So I mean, I duplicated it. So I didn't change it. I changed it the first one. I didn't change it to the second one. So this is supposed to be okay. It's D then E. So let me effect the change there. Let me see whether I duplicated it again or that will be question 2. Okay, that will be question 2. So I duplicated it once. Okay. All right. So let's go. So it will come to bear. You realize that, okay, from here, it is the U substance that will give us what? Okay, the term in S to the power 5. So E, what are we looking for? We are looking for, okay, which term? The sixth term. Okay, and in the question, because the positional term is given, we will use the R, the sum of what? Of your U to determine the R. So I will write, okay, comma, okay, and here I come and look at the sum. And you know that the sum of the U will always be, okay, R plus 1. So it means R plus 1 should be equal to 6. So therefore, R will be equal to what? 5. Is that clear?
So,
My professors, I hope you are following.
yeah.
Yes, please.
Okay, so
Yes, sir.
this is to state your R. So R will be equal to what? 5. If you can do, I always do it mentally, because if I'm looking for U sub, I have U sub R plus 1, but I want this to be 6. And the one situation will be this be 6 only when R is 5. So I will straight away do that without doing the rough work. But if you are not matured and you want to do the rough work, do it and later cancel. Is that clear? So
Yes, sir.
therefore, okay, I know I'm looking for which term? The system. Okay, you know will be, okay, U sub 6. And that will be equal to, hey, help me, let's go. 8 combination 5, because he said R is 5. 8 combination 5, am I right?
Yes, sir.
Okay, then what? Times what? 2, and it will be 8 minus 5, and that will give you
3.
3. Then times your x to what power? Okay, s 5, okay, to the power r. So that would be equal to, you can simplify. And because we have done this, you can see that that's what we have here. So instead of going through this, you know the answer that you get. You've done it already. So just come and infer. So 4, 4, 8, okay, x to the power 5. So it means, okay, the system will be 448 x to the power 5. That's 448 x to the power 5. Okay, so the system is the same as the term in s to the power 5. So that is another way of, okay, asking for this particular term. So if I want that particular term, the system, I can ask you to find the term in s to the power 5. Or if I want the s to the power 5 term, I can ask you to find the system. You get it? Or you get the same, okay, term that we are looking for. So the system indirectly in this question is the same as the term in s to the power 5. The third term indirectly is the same as what? The term in s was squared. Point well made, my professors. Okay,
Yes,
Prof.
sir.
Ali. Prof. Ali.
Yes, sir, please. I wanted to ask the question given like this. Can you like how will we can also use the other formulas like the combination?
How would you? I don't really get your question. Come again.
Please, a question like this, I was asked like, can you also like solve it like using the combination formula, the x plus y brackets?
Which combination formula are you talking about?
Is the um, egg combination?
In which formula? You've not mentioned the formula, so I can so mention the formula that you are referring to. Other than that, we cannot be on the same page. Which formula are you talking about?
That is the n combination 0 x and y 0.
Please, do you get her?
No.
I don't get her because if I don't get your question, I cannot answer your question. Okay, so please, okay, organize yourself, then come again. Is that clear? Because I don't get the formula that you are referring to, so I cannot answer, okay, directly to that particular formula. Okay, I saw another hand up while she's organizing herself. Please.
Sir, please, good morning.
Good morning.
Sir, please, I think sir, please, I get her. Sir, please, what she's trying to say is that if a question like this, so how will you know which formula to use? Whether the Pascal's triangle or the combination formula, the n plus the 1 plus n c, the 1 plus n combination cr plus. The combination formula. So the combination formula.
Somebody's burden.
Then the combination formula.
Okay, no problem. All right. You see, I got her, but I just wanted her to quote a formula. So it's like she doesn't know. You were also struggling quoting the formula. You get my point. I just wanted her to quote the formula for me to be sure that she knows the formula, but she was fumbling, and you were also doing same.
Yeah.
Okay, so let me come in. This is how I understood her. Okay, if I'm wrong, you tell me. Okay, other than that, I will answer you wrongly. Okay, so this is it. You are saying that how would you know that you are supposed to use, okay, whether the Pascal triangle formula. As for Pascal triangle, I've told you that that's not binomial theorem. That was to help us, okay, indirectly relate well with the binomial theorem, because you know it has a lot of deficiencies. Even the combination one has its own shortfall. Is that not it? Okay, so we said for you to easily know the coefficient, because in each term in your expansion will have a numerical coefficient, and for you to easily know the numerical coefficient, you have to rely on what? The combination. Okay, where the combination will fail will be when the exponent is what? Negative. So if in your expansion, okay, your exponent there is not negative, it's not, I mean, it's a positive integer. I've told you, combination is all, it's all that you need to know and you need to quote. So that's the more reason why from the beginning, okay, you can see that I said where your n belongs to a positive integer. So if your n be, so once I quote the formula in combination, then you should know that I've taken some values of n out, which will be the non-positive integers out. Because combination, we cannot use non-positive integers. Please, am I clear?
Yes.
So with this one, we are saying that yes, ordinarily someone who is not privy to this one, I said from the beginning, if I'm asking for maybe the system, what the smart one will do if you don't know this formula, okay, the general term, and therefore using it to find the particular word formula. If you don't know this concept, you don't say that I will sit down, okay, and let the marks go. What I will advise you to do, and that is if you have not been taught this, but once you've been taught this, I don't want anyone to do that. Please take note. What I will advise you to do is, if you are given this and you are asked to expand and give us, well, as for the general term, you cannot get it. If you don't know the formula, okay, how to generate, you can't get it. But the B up to E, you can, okay, salvage some marks there. Okay, however, if the question was find the general term and hence the term in S squared, then it means, okay, move on to the next question if you don't know how to use this concept that I just walked you through. But with this nature of the question, the A can go, but the B up towards E, you can salvage something, only that you will work harder. So you will give us all the expansion. And if you are looking for the term in S squared, just pick the term in S squared in that expansion and write it, then conclude. Therefore, the term in S squared, pick it and conclude with it. So in that expansion, the term in S squared will be, what do you have? It will be, where is it? Okay, so we had this value. So if you had expanded fully, you will get this as the term in S squared. So you go and pick it. The term in S to the power 5, you equally pick it. By then, you have expanded everything. So any particular term that we are interested in, you can pick it and, bring your, what do you call it, a term in your conclusion. However, with this one, you can see that we knowing the general formula and using the general formula to find particular terms, we only concentrate on that term. We didn't go and find any terms that would not be of interest to us, because you can see that we didn't find the first term, we didn't find the second term. They are not of interest to us. We didn't find the fourth term and the fifth term because they are not of interest to us, per the nature of the question. But from the basic understanding, from where you are coming from, you can give the full expansion and give us the particular term that we are interested in. But that's what we want to avoid. Is my point well made? Please, the person who asked the question, have I answered your question correctly?
Yes, sir. Thank you.
Okay, all right. Okay, and I guess you have to thank Prof. Akoli too for being your spokesperson. All right. Okay, so that will be it for the first part of the lesson. Not first part anyway. We are going for our water break. When we come back, okay, we'll look at more questions and others. Okay, so welcome back from the water break. Let's look at our second word example, our second question. Okay, it's not entirely different from what we did in the first one. Okay, just the binomial that we are expanding. Okay, that's where the living. So let's look at, read the question, underline the salient part, if any. Okay, so no salient part to underline. So first thing that you write is solution, then you come to your question number. So question number 2. Okay, question number 2, what information can you extract the binomial, okay, that you are asked to expand? So given, what are we giving? 3 plus, okay, 2x, all to what power? To the power 9. Is that clear, my professors? Okay, so at this point, we are good to go. So we go and look at solution to A. And when you are moving from 2 to A, you don't leave any line. 2 is a major question. Take note. Okay, A, we are looking for the general term. But before we can find the general term of this one, okay, if you are matured, you can choose not to quote the formula, like I told you, even in the overall expansion binomial. But now I'm going to assume, okay, we'll be quoting the formula so that it will stick. But once it sticks, okay, you can present it without quoting. So in this case, I'll write, but general term of A plus B all to the power n, okay, will be given by, is what? UR plus 1 is equal to, my professor is,
And
I'm waiting.
combination
Okay, let me erase this and erase what you have there then. Okay, right is, okay, and combination, let's
and
go.
combination are
R times
a to the
A
power n
n minus R.
Minus R, then B to the power
b
R.
to the power r.
Remember always when you add the exponents, okay, you should get your n where we started from. Okay. So now that we have this, we can say that therefore, okay, the general term of which expansion? 3 plus what? 2x all to the power 9. Okay, will be given by u r plus 1 is equal to here. Let's go. So let's compare rough work as our rough work. Okay, A is equal to what?
3.
Okay, B is equal to
2x.
2x. And N is equal to
9.
9. Okay, Prof. Marilyn, are you there? Are you able to follow? Hello, Prof. Marilyn, are you able to follow? Prof. Frank?
Yes, sir.
Okay, great. All right, so let's go. All right, so at this point, we are going to say that U sub R plus 1 will be equal to, we know our N, and that is 9. So 9 combination, you don't know your R. The R will change from one specific term to another. So combination R. Then your A, remember you said your A is 3, so you put it in bracket. So 3 to what power?
9 minus R.
9 minus R. Okay, then, our B, what is our B? You said
B to the
2x.
power R.
No, B will be 2x. Okay, but to what power? The power what? R. Safa.
Yes, please.
However, okay, this is it. This is how you are going to deal with this question. So we are not done with the final, general term. So this will be equal to, all right, so indirectly you are trying to say that what you have here will be equal to. So 9 combination. Listen carefully at this point. Okay, then, times 3 to the power, this is positive, so I can remove the bracket, no issues. 9 minus R. Then times, listen to what I'm going to write. Okay, here. You can see that in indices here, this is what you do. Always make sure that your X is standing alone. Okay, with its coefficient being 1. If it's not 1, use indices to split, because we know that this is the same as 2 to the power R, then S to the power R. Do you agree?
Yes, sir.
Okay, so that will give us 2 to the power R, okay, then times X to the power R. All correct?
Yes, please. Yes.
Okay, so this will be our final general term. So that once your S is standing alone, okay, if you want to determine its power, you can easily determine the power. Okay, that is from one question to. So we are done with A. Now let's go and look at B. This is where maybe I will put the spotlight on what? On Prof. Frank.
I'm going to come now.
Okay, Prof. Nuela, any issues?
No, sir.
Okay, you were talking. So let your attention be here. All right, so this is it. Now, B, what are we looking for? The term in S to the power 4. So for, once you get the general term, any particular term, you need a specific value for R. Okay, so the question will tell you the particular term is a particular term that will inform you as to how to get the R. So for which term? Okay, S to the power 4 term, or term in S to the power 4 is the same. S to the power 4 term. Okay, so we want the power of the X here, which is R, to be equal to what? 4. So again, you equate the two powers. So R will be equal to what? 4. If you equate and solve. When you equate it, R is already solved for. So it means R is equal to 4. Prof. Frank, you get a point now.
Yes. Right.
Okay, so once you know R is equal to 4, then I can write, therefore, okay, the term in S to the power 4. So therefore, term in S to the power 4, S to the power 4 term will be equal to, let's go.
It will be 9 combination
Combination
4.
for
So I'm going to write this. I know you are matured, I'm going to write this so that, okay, there wouldn't be any confusion. So I'm writing this. Okay, so comma, then it will be U sub what? Okay, R is 4, so it will be R plus 1, that would be 5. Is that clear?
Yes.
Okay, but if you are mature, you can choose not to write it and straight away write the equal to, just as I did in one of the questions. So that will be equal to
9
9
combination
combination 4,
4.
very good. Times 3 to
3
the
to the
power
power
9 minus 4, which we all know is what?
9
5.
minus 4.
5. So you can do it mentally. I've told you, if it's subtraction, addition, you do it mentally. Times 2 to what power? Power
4.
R is 4. I hope you are with me.
Yes.
Yes, please.
Then times s to what power? Okay, 4.
4.
Okay, in any case, we are looking for the s to the power 4. So these are all constants. So we are going to find their values individually, then later multiply. So that will be equal to, let's go. Okay, n combination 4.
126.
126.
126.
Okay, so 126. Okay, times 3 to the power 5.
243.
Come again.
243.
Okay, so 243. Okay, then times 2 to the power 4.
16.
Okay, so that one is, okay, so it's times 16, then times your s to the power 4. Is that not it? Okay, so you are one step away. So let me come in. Okay, assuming I've exhausted my page. Okay, so that will be equal to multiply 126, 243, then 16.
So please,
Mention it in terms of the digits.
raised to the power 4.
Mention it in terms of the digits. 1, 2,
489.
988
x to the power 4.
4, 8, 9,
Equal 8.
888,
x raised to the power 4.
okay, x to the power 4. If this happens to be a rough work, don't forget to strike it out. You get it?
Yes, please.
Okay, so you see, it's a little technical, but you agree with me that once you get the technicalities, it's very easy. Okay, you will do more, don't worry. So those of you who are not up there yet, don't worry, we will definitely get up there. All of us will be up there before we end the class. But if that will be possible, you have to, okay, or that will be realized, you have to ask all the necessary questions. So we are done with the B. Now let's go and look at what that of the C. Okay, so C. Here, C, we are looking for the term in s to the power 4. So for s to the power 6, forgive me, for, okay, s to the power 6 term, or for the s to the power 6 term. Okay, so our power of the x, let's go to the general one. Okay, the power of the x here is r, and that must be equal to the power of the x in the question. So 6. And when you equate, r is already solved for, so it means r must be equal to 6. Is that clear? Hello, my professors. Do you agree?
Yes, please.
Okay, so therefore, okay, which term? The term in
X raised to
s to the power 6, okay, will be equal to, okay, I'm matured, so I'm not going to write the u sub, okay, I will use the other side. Okay, so that will give me 9 combination was 6 times
3 raised to the power
9
9
minus 6,
minus
which is 3.
9.
Then times
2
2
raised to
to
the
the
power
power 6. Okay, then times x
X
To
raised
the
to
power
the
to the
power.
power 6. Papa.
Yes, sir.
Yes,
Okay, very good. Okay, so that will be equal to, okay, so 9 combination 6, your calculator. If you want to use your head, it's allowed.
84.
Okay, 84 times, okay, 3 cube, 27, times 2 to the power 6.
64.
Okay, 64. Then times your x to the power 6. Okay, so now you know what to do. This time, this. I'm waiting.
Sir, please. 145,152 x raised to the power 6.
145,152.
Yes. X raised to the power 6.
X raised the power 6. Very good. All right, so that will be it for what we have there. So now we know, okay, if the variable that we are looking for its power, if it's given in the question, okay, go and equate the given power in the variable in the question to the power of the variable in the general term, and solve for your Okay. Okay, so now let's go. Then, okay, D, the last but one. Okay, so now D, what are we looking for? For which term?
The fourth term.
Okay, so for the fourth term, I can use this as the same. Okay, so if you are looking for a particular term, fourth is a positional term. Am I right?
Yes, please.
And for positional term, do you use the power of the S to determine your R?
Also,
What do we use?
they use
We use the sub
So
of the
please,
U. Is
yeah,
that not it?
yes.
Okay, so now you know the difference. Okay, so let's go and look at the sub of the U. And the sub of the U will always be R plus 1. That one you always know. Okay, so your R plus 1 should be equal to what? 4. So meaning R will be equal to 3. If you like, you can do it as a rough work. R plus 1 should be equal to 4, meaning R is equal to 4 minus 1, which is 3. But we are mature, so it's equal to 3. So in this case, I write, therefore, okay, the fourth term, okay, will be equal to fourth term, which is U sub what 4, will be equal to, now let's go and substitute. We know the how that we need to substitute into our formula. So it will be 9 combination what? 3. Am I right?
yes,
Okay, times what? 3 to what power? 9 minus 3. So that will give us 6. Okay, then times 2 to what power? 2 cube. Then times what? Okay, x. Okay, also cube. Papa,
yes,
Yes, please.
only that, unfortunately, okay, after this substitution, we haven't done okay the r to the power 3. So r equal to 3. Okay, so with this one, we have to go the full stretch. Okay, so that will give us, we can infer. So it means the fourth term is not the same as the term in s to the power 4 or the term in s to the power 6. Is that clear?
yes,
It's none of them. So now 9 combination 3, I'm waiting, my professors.
84.
Okay, 8 4. Okay, then 3 to the power 6.
729.
729.
729 times
Then
2.
times 8.
Okay, 8. Then times what? Your
X
x
to the
X
power 3.
cube.
x cube. Okay. So now your final step. A huge number, but we can still write it.
489.
Come again. 4,
48.
489,888. Just like the
9,
previous one.
9, 8, 8, 8. Okay.
Triple eight.
Okay, then
X
what?
cube.
S cube. Okay, so let me put the fourth term. Okay, okay, so all right. So S cube. So now let's see whether then it means, so does that mean we did it? Okay, okay, it's the same, only that it's not, so the power is different. Is that not it? All right. Okay, so that's what we have there. Safa.
Sure.
Yes.
Okay, so at this point, I'm going to pause. Okay, do the E. Okay, and send me your answers via the chat. Is that clear? The 710. Send me your answers via the chat. All correct, my professors.
Yes, please.
Okay.
Yes, sir.
Yeah.
All right, so now, okay, welcome back. Okay, from your answers, at least I have, okay, the full conviction that most of you understand. You have one or two, okay, who are still not able to give us what the exact answers, but no worries. Okay, we'll definitely get there. So let's go and look at the solution together. Maybe that will help them to know what went wrong and at what point. Okay, so E, we are looking for which term? So for the, okay, seventh term, okay, we will need our R, comma, R must be equal to, so if we are looking for a positional term, particular term positional, okay, we said we will use our sub. So that means R plus 1 should be equal to a 7. So meaning R will be equal to 6. Do you agree?
Yes.
Okay, so now you come and write, therefore, once you know your R, you are in a pole position because your formula will now involve only R. Okay, or now involves only R. So what do we have? We are going to get therefore, which term? Seventh term. Okay, we know will be equal to, I know it won't go there, that's why I didn't, and I don't want to squeeze two, so I came down. So let's go, that will give us what? 9 combination 7. Okay, then you are going to get 3 to the power 9 minus 7. So 9 minus 7 will give us 2. Then times what? You are going to get 2 to the power 7. Okay, then x to the power 7.
Say, please,
Six.
R is equal to 6.
Okay, so very good. It means you are following. All right. So, okay, so R will be 6. Okay, I use R to be equal to 7. Okay, so you are following. Obviously, at this point, okay, I will be doomed. So make sure you equally. So that will be, so you are alive with me. So let me clear that one too. And okay, seems okay. All right. So very good, at least. So those of you who couldn't get it, you are fine now, right? So combination 6. This will give us okay 3. Am I right?
Yes.
Okay, and therefore this will give us 6. This will also give us 6. So at this point we are good. The rest becomes calculator work. Is that clear?
Yes,
Yes,
sir.
yes, sir.
Those of you who didn't get it, I guess you are now fine. Any questions, especially those who didn't give me or give us the right answer?
Sir, please.
Okay, Prof. Robert, are you fine?
Sir, please, may I give you an answer, but I'm not sure if it's correct.
Okay, but you should know from here, you can use your calculator even to do the coefficient straight away. 9 combinations so times 3q times only that you don't do that in your presentation. Do this one, get its value, this one, its value. Okay, but the answer was okay. So those who had the, let me check, I can tell the right answer. Okay, okay, the answer is supposed to be 145,152. Okay, s to the power 6. Prof. Robert, all right, so that's supposed to be the right answer. Okay, so now, okay, let's move on to the last question, which will involves extra, something extra, but not entirely extra. So that one, I will do only the D and maybe the E, or guide you, okay, to do the E. So, but I have to go through A anyway. So when okay, the third example, when 2 minus 3x to the power 9 is expanded in ascending powers of x, find, so ascending powers of x, so you don't have to do any rearrangement. So if you expand, so it means okay, we are going to go by what we have there. So solution to question 3, so ascending powers of x. So that will guide us to. So what do we have given? And here I want you to listen carefully. 2 minus 3x all to the power 9. Okay, again, so now what do we have? We know A. You always, so even if you were not asked to find a general term and you are asked to find a fourth term, you know you cannot get the fourth term without getting the general term. Is that clear?
Yes, sir.
Okay, you cannot get a particular term. So in this case, okay, so I'm going to quote general term, but okay, the general term of a plus b to the power n. Okay, let me present this maturely. Okay, so that at least you can equally adapt. Okay, so now let me go general term. So quote the formula. Oops. Okay, I'm coming. Okay, so let's see. All right, so general term. So this is how I want you to deal with it going forward. Yeah, you know, in your mind, you are dealing with general term of what? A plus b to the power n. So you can write general term, okay, will be u r plus 1 is equal to, so don't write general term of a plus b, no. So general term will be a plus b, okay. Oh, what is happening? I've started exhibiting symptoms. All right, okay, so let's go. Okay, so that will give us what? Let's go. N combination here. R a to the power n minus r b to the power r. Is that not it?
Yes.
Yes, please.
So I can say that therefore, now you know this is not the general term of this. It's the general term of what A plus B. You should know by now. So therefore, okay, general term of 2, okay, minus 3x all to the power 9. Okay, will be what? UR plus 1 is equal to, let's go. If you compare, let's do that as a rough work. If you are matured, you can, rough work will not be necessary. A will be equal to what? 2. What will be
2
B?
minus 3x.
Very good, you people are matured. Okay, then what will be our N?
9.
9. Okay, so now we are going to get 9. Okay, combination. Then your A, which is what? 2. So 2 to the power, okay, 9 minus R. Okay, then your B, which is what? Minus, you put that one in bracket, very critical. Minus 3 what?
X.
X. Okay, to what power?
9.
Okay, to the power R, not 9.
8, sorry. Sorry.
All right, okay. So that is it. My professors, I hope you are following. If
Yes,
this
please.
is your rough work, don't forget to strike it out. Okay, so now we are not done. This we can further simplify. So that will be equal to. So let's go. Okay, we are going to get what? 9 combination R. Okay, 2, there is so dots. The bracket can go because it's positive. So dot 2 to the power 9 minus R. Then dot, with this one, you know, I said anytime you have something multiplying the x and it's not 1, okay, you indices to split. So that will give us minus
Minus 3 to the power
to the power
r.
R, then times what? X
X to the
the
power
power
r.
R. Do you agree?
Yes, please.
So that's what you all write. Okay, so please take notes. I advise you from the beginning. Okay, and if you encounter, that's the more reason why I picked this question. Okay, at this point, remember here the bracket is necessary. Okay, you have to put this in brackets. It is the whole of negative 3 that is being raised to the power r, not, okay, if you write it without a bracket, then it means you have to raise 3 to the power r and you negate it. That's the meaning. You get it?
Yes,
So
please.
when what you have there, the coefficient, any of the quantities I've told you that you are substituting is negative, please take note, you cannot remove the bracket. So it means if this was also negative, then the brackets should have been there. Okay, here when you are splitting, you can see that one of the terms will be negative to a certain power. So once that term is negative, okay, put it in bracket before you bring the power. After,
Yes.
okay, so now that we know the general term, so at this point, that's how far we can go. So that's the general term formula. So with this, you can find the fourth term. The fourth term, R must be equal to what?
3.
3, because you get R plus 1. That one, you use the sub. The seventh term, R must be equal to what?
6.
6. So you know, you go and substitute. I've told you it's not because of B and C that I picked this question. You can see that this, the D and E, okay, are somehow different from what we were asked to find. So here, you were asked to find, or what we've done so far, I should say, we are asked to find the coefficient of S what Q, the coefficient of S Q. So you are looking for a particular term. That particular term is the S Q term. But the question is asking you to find the coefficient. So if you don't know that particular term, how do you extract its coefficient? You get a point. So the term that you are interested in, you know the power of the x. So in this case, let me skip and go to the e and let's look at how best we can present our solution. So as usual, if you move from a to e, you leave a line. So in this case, we are looking for what? Okay, so before you can find the coefficient of s cubed, you need to know the term in s cubed. Is that not it?
Yes.
Before you can find its coefficient. Please, are you with me?
Yes, please.
Okay, all right. So at this point, I can write for the, okay, s cubed term. Okay, if you compare, r must be equal to what?
3.
3. Please, do you all agree?
Yes.
Okay, so R must be equal to 3. So let's go. So we are going to get here. So here I won't write therefore. I won't write therefore. So I will write this implies that, okay, S cubed term. Because the question didn't ask me to find S cubed term. It asked me to find what the coefficient. Is that not it?
Yes, sir.
But I will need that particular term before I can use that to draw my concrete the coefficient term. I'm going to get here. So let's go. Here, R will be equal to 3. So we get 9 combination 3. Am I right?
Yes, sir.
Yeah.
Then 2 to what power times 2 to what power? 9 minus 3.
9 minus 3.
6.
6.
Okay. Then
6.
into, don't forget your bracket. Minus 3 to what power?
3.
3.
Okay. Then times what? X what? Okay.
X.
Power 3. So S cubed.
Um,
So that will be equal to 9 combination 3.
84.
84. Okay. Then times 2 to the power 6.
64.
64.
Okay.
54.
64. Okay. Then times, okay, minus 3. Okay. Cube. That will give us minus 27. Am I right?
Yes, sir.
Yes,
Okay.
please.
Then times X cube. Okay. So now give me, okay. At this point, I could have even drawn my conclusion, but because it's the first example, let's go. So multiply 8 for 64 minus 2. So you get minus
145.
Minus 145.
152. X cube.
S cube. Okay, but the question asks us to find what?
The
The
coefficient.
coefficient of S
Okay.
cube, not the S cube term. So I will come and write, therefore, now I'm doing my coefficient and conclusion. Therefore, and I've told you, always write the math, if possible, followed by the English. So therefore, minus 1, okay, 4, 5, 1, 5, 2 is equal to coefficient of S cube. Afa,
Yes, please.
Yes,
Yes, sir.
please.
Yes, sir.
or someone can write coefficient of S cube is equal to this. But I've told you, write the math first, followed by the English. Okay. So with this, I believe you can find the coefficient of S to the power 6. So it means you have to find the X, okay, to the power 6 term, okay, and extract only the coefficient as in your conclusion. Is that clear?
Yes, sir.
Okay, so you've done so well. Okay, so in actual fact, this was supposed to be the continuation. If you were supposed to do everything here, okay, one slide wouldn't have been enough. Okay, I explained the B and the C, and that's of the E. Okay, so Prof. Frank.
Oh, sorry, was a mistake. Sorry.
Okay, all right. Okay, so now as for this one too, I guess you should be able to do it. Okay, let me see. Okay, let's do one of the. This is quite. I mean, it's a little different from what we've done. So let me see that if you have more than okay at least. Okay, so let me introduce you to that. Okay, so quickly, question 4, and that will be it. So question 4, listen and listen attentively. This one you can see that so far all of them, the binomial that we have, the x, the power, okay, 1. So all the questions that we've done, you can see the power 1 so far. Okay, the power 1 so far, all that. But now let's see. Okay, this time round, that is not 1. So let's see what is going to happen. How best you deal with your algebra. If you understand what you've done so far, okay, what I'm doing, if it will not be necessary, you will know that's okay, that's how you are supposed to, okay, deal with it. But nonetheless, so given, what are we supposed to expand? 3 plus what? 2s squared. Okay, the whole of that to the power 7. Alpha. So copy
Yes,
and
sir.
paste. So we are going to do A. But before we can do the A, okay, you will need a general term. Is that not it?
Yes, sir.
A is a particular term. B is also a particular term. So I'm going to find the general term before I come to A. So that it will be a general information for me to rely on the A and B. So I won't write A, then come and find the general term and use it to find that particular term. Other than that, if I'm going to B2, I have to, okay, find the general term again. So in that case, I'll write, okay, but, okay, the general term of what? So general term, okay, you know, will be what? UR plus 1 is, is equal to, let's go,
Let's copy.
N combination R, A to the power
Okay.
N minus R, B to the power R. Assume. I want you to be quoting this. Okay, so this implies that, okay, so here I will write therefore because the question didn't ask me directly to find the general term of this. Is that clear? Unlike the previous one. So if the question is not direct, you don't conclude with it. So I write this implies that general term of, okay, 3 plus 2x squared all to the power 7. Okay, will be given by,
Therefore, copy.
okay, so u sub r plus 1 will be equal to 7 combination r. Then what is our a? So we are comparing mentally. A is 3, is that not it?
Yes, sir.
To be 3 to what power? 7 minus r. Do you agree?
Yes, sir.
Okay, and what is our b? 2x squared. Do you agree? To
Yes,
what
sir.
power? To the power r. Is that clear? Okay, now let's see what is going to happen. Something interesting will happen here. Oops, our time is almost up. Okay, so that will be equal to here. Let's go. We can further simplify because the coefficient of your x there, okay, is not 1 as advised. Okay, so 7 combination what r. Okay, then times the 3 that you have there is positive, so you can ignore the bracket. So 3 to the power 7 minus r. Okay, then times the coefficient here. Okay, it should have been this coefficient to the power r is positive, so I can ignore bracket. So it will be 2 to the power r. Then times what? You are going to get s squared to the power r. So if you have s squared all to the power r, indices, if you have a to the power m all to the power n, it will be a to the power mn. Do you agree?
Yes.
So that will give us s to what power? 2r. Do you agree?
Yes, sir.
Afa.
Yeah.
Okay, so that will be it. So in this case now, I know my general term formula, so I can come and find a, my particular term. So for x to the power 10 term, okay, we need to go and get our r. So let's see, we can see that it means we want the exponent here of the x in the general formula to be the same as 10. So under one circumstance, remember I told you, equate the power here to the power that is given. So your rough working directly, we are going to get, okay, 2r is equal to 10. So it means r will be equal to 5. Is that clear?
Yes.
You get the point now. So after equating, you have to solve for your r. But so far, you can see that after we equated, r is already solved for. Do you get my point?
Yes.
But this situation is not like that. So we know that r will be equal to what? 5. So I write therefore my x to the power 10, okay, 10, okay, will be equal to, okay, Prof. Gideon.
Can you come again in finding the answer? Can you explain it again?
Okay, so I said whenever you are finding, okay, a particular term and you know the power of the s or the power of the variable, what do? Just equate the power of the variable in the question to the power of the variable in the general, okay, term. So the power of the variable in the general term is 2r. You equate it to the power of the variable. So it will be 2r is equal to 10. Then you solve for your r. Okay, under what circumstance would this be 10? Only when r is equal to 5. Is that not it?
Yes, yes. Yeah.
Okay.
Thank you, sir.
Okay, you are welcome. So now let's go. My profs, are you there?
7,
So you are going to get what? 7
combination 5
5
times 3 raised to the power 7 minus 5.
which is what?
Which is
2. Okay, then times
2
2 to what power?
times 5.
Okay, 2 to
8.
the power 5. You mean?
5, yeah.
Okay, then
Times x
times X to the power 10.
It's
Okay.
10.
Then now, you know, the rest will be calculator work. Use your calculator to do that. I'm waiting. Let's finish with that. Then I know that we are fully insured and covered.
21.
Come again.
21.
21 for the 7 combination 5. Okay, then times 3.
9.
We all know is 9. Okay, then times 2 to the power 5, which is
32.
32. Then times what? X to the power 10. Okay, so the last one, you use your calculator to do. Okay, the whole of the thing that's there.
So please, 6048 x raised to the power 10.
Okay, x raised to the power 10. Alpha.
Yes.
So it's not always that straight away when you equate your exponent of the x in the general term formula. Okay, you have what? What you have the x power in the term that you are asked to find. You straight away get your R. Sometimes you need to solve for your R. Okay, all right. As for the positional terms, always you have to solve for your R because it will be R plus 1 is equal to that position, that you are looking for that term. Okay, and you solve for your R. Alpha.
Yes, please.
Okay, so any questions at this point before we finally bring the curtains down? Please, no one is leaving. Any questions at this point? My professors, no questions? Okay, Prof. Gideon.
So it means the second one, the B, for the term x to the power 12, you equate 2r to the 12.
Yes, so it means R will be equal to 6.
Okay, sir. So
you get it? Okay, so assuming maybe, this is just by the way, assuming maybe I ask you to find, this is just by the way, maybe it will help you in your project, or your group assignment that is coming. Assuming I ask you to find x to the power 13, look at what is going to happen. That will give us what? 2r is equal to what? 13, is that not it? Okay, will you be able to solve for your r?
No,
R
sir.
will be equal to what? 7.5, is that not it?
Yes, sir.
Or 6.5, it's 6.5.
6.5.
Okay, so since in any case, your R is a fraction. When your R is negative, it's a fraction. You know, combination, your R here cannot be negative. The least value is supposed to be 0. It cannot be a fraction too. So in that case, it means there will be no term in x to the power 13. Point well made, my professors.
Yes, sir.
So after solving for your R, if your R doesn't give you a positive integer, then it means that particular term that you are looking for does not exist. Safa.
Yes.
Okay, so on this note, let me take the attendance then. Okay, we call it a day. You've done well. I'm so impressed. Somebody's video is on. Was it intentional? Okay, so thank you very much once again, for a very successful lesson. Okay, God bless us all. Bye-bye.
Right?